In this example, we want to solve for x is between 0 and 360, the equation 5 cos squared x equals 3 times 1 plus sine x. So far what I don't like about this equation is we have cos squareds and sines on its own. So we know an identity relating sine and cos, which is sine squared plus cos squared equals 1. So with this cos squared that I have here, I'll rearrange this equation for cos squared, substitute this in, and I'll get an equation all in terms of sine then, which will be a lot nicer to solve. So we know that cos squared x from this identity is 1 minus sine squared, and if I'll sub that in to our equation and expand this, we should get a nice quadratic in terms of sine. If I expand all of this, I get 5 minus 5 sine squared equals 3 plus 3 sine. And if I put all of this onto the same side, I'll put it all onto the right hand side, just so I get a positive sine squared. And from there, we can factorise. So I'd, for this one, just probably put it all into your calculator. And we get some solutions for sine x. So my first one is 2/5, and my second solution is -1. So using our calculator, we can just do sine to the -1 of 2/5, and that gives me a value of x equals 23.6 degrees. The sine to the -1 of -1, you probably already know this one, but in your calculator it'll give you -90, and I'll show you this one on a graph as well. So the sine graph starts at 0, in the calculator, the sine graph for sine x is -1 gives us a value of -90 because that starts here. But we know that sine x is -1 also at 270 degrees. So we can see that one from the graph. So you have to know your graphs well for these. The other value that we've got is at sine 2/5. So I'll draw 2/5 on my sine graph, and we'll look at the solution points here. So across that line, we've only got 2 points that cross, so one not very far into the x-axis, and then one just before 180. So we know that we've found one already. This corresponds to our 23.6 that we've already found. We also want to find this one just before 180. But if we know that this distance here is 23.6, then we can just go from 180 and step back. So the other solution there would be 180 minus 23.6. And that gives us 156.4 degrees. So we have two solutions from that one, and for -1 we only have one solution, and that's at our 270 degrees. So altogether for this equation we have our three solutions between 0 and 360 for x equals 23.6 degrees, 156.4 degrees and 270 degrees. In this example, we want to solve for x between 0 and 360, and we have 4 sin x is equal to 3 tan x. So at the moment we've got a sine and a tan. We know that the identity for tan is sine divided by cos. So if I sub that in first and see what we get, so 4 sin x equals 3 sin x over cos x. So that works out quite nicely. If I multiply both sides by cos, we'll rearrange it a little bit, play around with it, see if we can get something nice out of it. We get 4 sin x cos x equals 3 sin x, and then how I like to just put everything on the same side, we have 4 sin x cos x minus 3 sin x is equal to 0. So if we can factorise this, then we have our solutions to start with. What's nice about this one is they both have a sin x in, so I'll take out sin x, and what I'm left with is 4 cos x minus 3. So if this equation equals 0, and it's two things times together, either the first one must equal 0 or the second one must equal 0. So we know that if sin x equals 0, sin x to the minus 1 of 0, we know is 0. So that's where our sine graph starts. The other one that we have, if we rearrange this for cos x, we'll go cos x equals 3 over 4, and if we do cos to the minus 1 of 3 over 4, we get x equals 41.4 degrees. So that gives us our two starting solutions. One of them is in terms of sin x and one is in terms of cos x though. So I'll start with that sin x graph. So we know that that one starts at 0. For sin x equals 0, we know we'll have a few solutions there. So we've got our first one at 0, it also crosses 0 at 180, and then meets 0 at 360 again. This one is from x is between 0 and 360, but we have a strict inequality there, less than or equal to x for 0, and then less than 360, the last one. So we won't include 360 in that solution there. The other one that we have for our cosine graph, so the cos graph starts at 1, -20, 270, 360, goes between 1 and -1. We have our first solution there as 41.4, and this is because of 3/4. So if I put 3/4 on there, go across, and I've got to 41.4 degrees there. So that makes sense that it's roughly in between 0 and 90. But we'll also have another solution for this one. So if I continue in that line, my next solution will be somewhere between 270 and 360. With this one, where people have gone wrong in the past is deciding whether to add it to 270 or take it away from 360 for this 41. And to show you this part, if I go from 0 here up to 41, that is that part of the curve just coming down from the top. So the similar part of the curve just coming down from the top there will be 41.4 degrees in that direction. So I'll have to go from 360, take away 41.4 degrees. And my solution to that is 318.6. So I just get two solutions from that graph, two solutions from the other graph. So altogether, I have my 4 solutions of x of 0, 41.4 degrees, 180 degrees, and 318.6 degrees. In this question, we want to solve for thetas between 0 and 360 degrees, 2 cos squared minus cos minus 1 equals sine squared. So here we've got some cos squared, some cos, and some sine squared. So we want to change these either all into sine or all into cos. Because I've got a cos squared and a cos, I'll change this sine squared into a cos. So our identity for sine squared, we know that sine squared plus cos squared equals 1. So we can easily rearrange that to see that sine squared equals 1 minus cos squared. So if I sub this into our equation, we have 2 cos squared theta minus cos minus 1 equals 1 minus cos squared. Now if I rearrange all of this, I'll put it on one side, so we get a lovely quadratic all in terms of cos. Then from this point we can factorise. So from there I'd go probably straight to your calculator to solve 3x squared minus x plus minus 2. And we get two solutions. Our first one, cos theta is 1, and our second one, cos theta is minus 2/3. If you want, you can factorise these into brackets first and then write your two solutions. So we've got a lot of work to do for this one. Our first step is to find our value of theta when cos theta is 1. So from calculator, that'll give us 0 degrees. You probably already know that one. The other one for minus 2/3 in the calculator will give us 131.8 degrees. But that's not our only two solutions. So if we draw our cos graph, not very to scale, but we've got each of our values on there between 0 and 360. Our first solution for was cos theta equals 1, and we can see that that was clearly 0. We'll also have another one of those over here, so that corresponds to theta equals 360. So we'll get two solutions from cos theta equals 1. We'll also get two solutions from cos theta equals minus 2/3. So if I look at minus 2/3 on my graph, if we go along first, we get to our first solution. So that was 131, which the calculator gave me. That fits nicely between 90 and 180. So if we carry on with this line, we'll find our next solution of minus 2/3. So this one should fit nicely between 180 and 270 on that graph. So the easiest way to calculate this, some people like to find the difference between 90 and 131.8 and then take that difference off 270, because that would work. Or we could also do, we know that this distance is 131.8, and that's for all of that curve. So because it's symmetric, for all of this part, this distance here will be 131.8. So we can do our next value at 360 minus 131.8. So that should give us a value of 228.2 degrees. And that is all 4 solutions altogether. So we have finally theta equals 0 degrees, 131.8 degrees, 228.2 degrees, and 360 degrees. And that's our full 4 solutions for that equation. For this question, I want to solve this for theta between 0 and 360. So we're nowhere in degrees. If this was in radians, it'd be between 0 and 2 pi. We want to solve the equation 3 sine squared minus 2 cos squared equals 1. So we have both sine squared and cos squared at the moment, which we don't like. So we're going to put them in either into all sines or all coses. The identity that links sine squared and cos squared is sine squared plus cos squared equals 1. So we can use this identity. I'm going to rearrange that for sine squared and sub this in. If you rearrange it for cos squared, it should work exactly the same, and I'll post that solution as well. So from the equation that we have, if I sub in what I know for sine squared, so that's 1 minus cos squared, I have 3 times 1 minus cos squared minus 2 cos squared theta equals 1. If I expand all of this, and then collect my cos squared terms, nobody likes a negative cos squared, so I'll move that one to the other side and move the 1 over. So I know that cos squared is 2/5. Where most people lose marks in this one is when they take the square root. So it sounds like an obvious thing to do. But when we take the square root of 2/5, we don't just get one solution, we'll get 2 solutions. So our plus and minus square root of 2/5. So if I put these into my calculator, I'll get my 2 values of theta. So cos to the minus 1 of the square root of 2/5 is 50.8. Cos to the minus 1 of minus the square root of 2/5 is 129.2. Those aren't my only solutions, so we're solving this for cos theta. So it will help if you can draw out your cos graph. We'll go between 0 and 360. And we have our first solution is for the square root of 2 over 5, which would be about here. And our other solutions for the negative root 2/5. So we know that we've got one nice solution already. When we go across to here, we got our value of 50.8, and this is what that corresponds to. We'll also have another solution up there. So if we continue along that line, we'll have another solution just past 270 degrees. To work this one out, we know that the horizontal distance here is 50.8, and that was at that curve coming down. So if we look at the cosine curve at the other side, that horizontal distance there from symmetry will be 50.8. So my other solution would be at 360 degrees minus 50.8. from that we get 309.2, and that fits exactly in where we'd expect just over 270 here at 309.2. For my other solution of 129, so if I draw across my line so far from minus 2/5, my first solution fits in nicely, over 90, less than 180, but if I continue on that line, I've got my second solution. So this one should be between 180 and 270. Because this graph is symmetric around 180, we know that this horizontal distance here of 129.2 must be the same as this horizontal distance here. So to find that value, we can do, again, 360 minus 129.2. From that value, we should get 230.8. And between 0 and 360, that is our 4 solutions. So our 4 solutions for theta are 50.8, 129.2, 230.8, and 309.2. So if you want to pause this video here, go through that again, but instead rearrange this initial sine squared plus cos squared equals 1 for cos squared, and see if you can get the equation in terms of sine then, and try and get the same answers again by drawing your sine graph. In this example, we have 4 sine squared x plus 9 cos x minus 6 equals 0, and we need to solve this so x is between 0 and 270 degrees. What's wrong with this equation at the moment is that we've got a sine squared and a cos, so we need to convert this either into all sines or all coses. An identity that links sine and cos is sine squared plus cos squared equals 1. So I can use this on my sine squared here to rearrange this for all cosines. So I know that sine squared x equals 1 minus cos x. So if I sub that into my equation, it'll be all in terms of cos instead of sine and cos. If I expand all of this, and I'll move everything over to the other side. So I'll just swap all the signs. We get a lovely quadratic in terms of cos. So I've got 4 cos squared minus 9 cos x plus 2. So to solve that polynomial, you can go straight to your calculator. and you should get your first solution for cos x equals 2, and another solution for cos x equals 1/4. So if we know this cos graph, you get a lot of practice of drawing all these graphs. We know that the cos graph and the sine graph go between 1 and -1. So this value for cos x equals 2, if you put it into your calculator, you'll get an error because the cos graph will never go up to 2. So no solutions from that graph. But for the cos x equals -1/4, we'll be able to get some solutions. So if you do cos to the -1/4 on your calculator, you'll get your first solution of x at 75.5. So if I draw this one on the graph, 1/4 is about here. If we go across, then close to 90, that fits in well with our 75.5 there. However, if we continue in this line, we'll have another solution. This solution will be just past 270 degrees. So it helps to know exactly what solution that we're looking for. If we know that the horizontal distance here is 75.5 degrees, and that's for that part of the curve, this cos graph is symmetric, so the part of the curve there will have horizontal distance of 75.5. So we can work backwards to do 360 minus 75.5. From that, we get 284.5 degrees, and that's our other solution. So from all of that, we'll just get two solutions between 0 and 360 of 75.5 degrees and 284.5 degrees. However, in this one, we have to repeat this between 0 and 720. So we know that the cos graph repeats every 360. So now that we've found these two solutions between 0 and 360, for each of them, we can just continue to add on 360 degrees. So in total, we've got 4 solutions for x. We have 75.5 degrees, 284.5 degrees, 435.5, and 644.5.